Welcome to our channel. Today we're diving into the fascinating world of space-time and the general theory of relativity. These concepts might sound complex, but we'll break them down into simple, relatable terms that anyone can understand. First, let's talk about space-time. Imagine space-time as a stretchy fabric that conforms to the massive objects placed on it. Think of a trampoline. If you place a heavy ball in the middle, the trampoline bends under the weight. This is a simplified image of how mass can warp space-time. Now, picture this in 3 dimensions, like a bedsheet. Instead of just bending down, the fabric of space-time bends in all directions around a massive object, similar to how the Earth orbits the Sun. The Sun's mass curves the space-time around it, and Earth follows this curvature as it moves. This brings us to the general theory of relativity proposed by Albert Einstein in 1915. According to this theory, gravity is not a force pulling objects together, but rather the result of masses curving space-time around them. Essentially, objects move along the curves in this fabric of space-time. Here's an everyday example. Imagine you roll a marble across a stretched flat sheet. It travels in a straight line. Now, place a heavy ball in the middle of the sheet and roll the marble again. The marble will curve towards the ball, following the shape of the sheet. It's not directly attracted to the ball. It's just following the curved surface. You might be wondering how this affects us in our daily lives. GPS satellites, for instance, have to take into account the warping of space-time to accurately measure distances on Earth. Without factoring in general relativity, our GPS systems would be off by several miles. Another interesting phenomenon is time dilation. According to general relativity, time moves slower in stronger gravitational fields. This means that a clock closer to a massive object, like Earth, will tick more slowly than a clock farther away. Astronauts on the International Space Station experience time slightly faster than we do on Earth. Black holes are perhaps the most extreme examples of space-time curvature. They are regions in space where gravity is so intense that not even light can escape. Imagine placing a super heavy ball on our sheet. It would create an infinitely deep well, and once you fall in, there's no coming out. Einstein's general theory of relativity has profoundly impacted our understanding of the universe. It helps explain the motion of planets, the behavior of light near massive objects, and even the expansion of the universe itself. In summary, space-time is the fabric in which all objects in our universe exist, and it's influenced by mass and gravity. General relativity explains how this fabric bends and shapes the behavior of everything from marbles to planets.